Hello dear students, this is ISI subjective solution. After 1, 2 and 3 in this I will be doing question number 4. चलिए सवाल को देख लेते हैं. Let g lies between 0 to infinity be a differentiable function whose derivative is continuous and such that g of x is x for all x greater than 0. If x is not the identity function, then prove that g must be strictly decreasing. Okay, so first of all, remember that continuity is a very prerequisite for differentiability. This is very important. So without continuous, we cannot differentiate at that particular point. But being continuous leads to differentiability is not guaranteed. So this is the very basic formational structure. So now g of x, so this is the stuff they have given, and that is equal to x, so function of a function. Now if we differentiate this thing with respect to x, so first order derivative first, and then g of x, and then within inside of it, so that will be g dash x, and derivative of x will be 1. So this is the first order derivative. Now g dash x cannot be 0. Okay, so if g is not identity, and so g dash x not equal to 0, and for x greater than 0, so hence g dash preserve the sign, so g dash lies between so g dash x lies between 0 to infinity. So this has been given already. Now g dash x is increasing. Why? Because this thing is giving you the positive. Okay, so let this thing be positive first. Okay, if x is positive, so if x is positive, this is positive, so here this will be increasing, and not only increasing, it will be strictly increasing function. Okay, so now if gx, if this function gx or is giving you x, or f of x equal to x, so when this function is giving, so this is a x directly function, and this must be a passing through origin function, no constant part, passing through origin. This system is passing through origin. So as a result of that, we can say that as this is not an identity, and g of x may be greater than x. This is case 1. Case 2, g of x is greater than x, and we will take another case, g of x is less than x. So g of x is greater than g of x, and that is greater than x. This is done. Okay, but we have taken g of x equal to x, so this is not possible. Case 3, if we take that g of x less than x, so g of x, similarly g of x is less than x. Okay, so the assumption g dash x greater than 0 is not valid in this case, so this is also applicable, but this will create a strictly decreasing structure. So now what is the difference between increasing and decreasing? If the first order derivative of something is greater than 0, this is called strictly increasing. If it is greater than equal to 0, it is only increasing. So there won't be any confusion point, there will be equality is there. Okay, so g dash x less than 0 for x there, so g is strictly decreasing structure. So finally we reach to that situation that this pattern is applicable for this thing, and without any contradiction. So this proves that this is a strictly decreasing pattern.